Hello everyone. This video I'm going to teach you how to create the ladder diagram for controlling automation process. Unfortunately, you never have had experiences to create ladder diagram to control the hardware, the devices, or automation process before. So I suggest you use the PLC simulator program for practice and test your knowledge. You try to create a ladder diagram and put in your uh, PLC simulator for controlling the virtual parsing, virtual automation process, right? Okay, I will use it. Use this the program, right? This program, PLC simulator, and inside of this program, having the parsing. No, sorry, have the virtual automation process inside. Right now, I assume you all already done about installation is program already, right? Let's say I bring you to this program. This program there are the level, right? The ranking needed on your knowledge, right? You practice step by step, level up, right? Thin, the basic, right? Uh, Basic and the easy does it, and the beginner challenge and intermediate, and higher level is advanced challenge, right? Okay. uh, let's get started. I start up at the beginner, challenge, right? I select on the time control traffic light, or click on that exercise, and the exercise did exercise, right? Okay, did exercise. Okay, did the compose of this area for information, problem information, and this area right side below the PLC simulator. Okay, on the top in the area for process, virtual automation process, right? This one. Okay, the emulator from the real one, right? Traffic light, and this uh, website at the top website is the uh, control panel for switch simulator, and write your program, your ladder diagram to the PLC simulator, and this one is going to the main menu, right? The menu and the level knowledge, right? Okay, easy and intermediate, and I told you before. Okay, start up at the edit ladder. If you need to write the ladder diagram, this one is the first ladder diagram about this video, right? Okay, and I explained this bit for you about the panel of the PLC simulator, and this one, the push button number one. Okay, the simulator PLC is a wire the button one. Okay, wire the cable, wiring the cable from the button to the input port. Name is X20, and the button number two, wire to the input port 21, right? And okay, there are the four push button, and there are the toggle switch, two button switch, right? Is toggle, it can be locked, right? That is the wire, the cable from the toggle switch to the input. Name is X24, 25, right? And the size of the output. So the output is wire. The output is the lamp. Right? The lamp is the four lamps. There are the input port, output port name is 20, 21, 22, 23. There are the four lamps. Right? Okay, this zone is the editor. You can write the diagram in this zone, right? This zone at the below area, right? Okay, going to edit ladder diagram and start up at the ladder diagram. Okay, you going to think about and follow me. I will propose the idea and you follow me and catch up my thought, right? Step by step, right? Okay, first time I'm going to hit the button F5. F5 is the shortcut key, right? When you create the signal, create the symbol is the numbering open. Numbering open, the contact is open, right? In the regularly it open, right? When you hit the button and change to close, right? I use the symbol like this, right? Click F5, right? Okay, it show up on your screen, right? Enter symbol. Okay, right now I define the name is X20, X20, something like this, right? Okay, put your button. Okay, and this, oh, okay, if you need to write and draw the line with horizontal line, you can use this way, right? Easier way. Yeah, okay, you can draw by yourself, draw by the use the keyboard chip and press the button, and the button is go up, go down, and go right, go left, right? There is a four button in your keyboard, right? Define the direction. You go right, go left, go up, go down, right? And the chip, right? Okay, I will show you. Now you click on here. You need to draw the horizontal line and going to touch the left vertical line, right? Okay, I will click on the F10 F10 and chip and go right. Okay, it draw the line already. And very easy, very easy. Okay, if I show you, I need to control uh, the lamp to be lit, right? I need to define the output. I press F7 is Y20. Okay, this is the example. Let me show you the basic first before I going down solve this problem because this problem need you solve the problem, and this exercise define the problem like this. Okay, when you push the button X20, right? Okay, control the output Y0. Y0 is lit 10 seconds, right? And 10 seconds is done. Okay, show up is yellow, is Y1, it's Y1 lit 10 seconds, right? And step last step, okay, show up is green color, right? The right green color is show up and lit 10 seconds, right? Okay, this question, this constraint given by the problem. Okay, I think it's easy, very easy. I will set up and add up the constraint, right? And the more complicated, a little bit more, right? Okay, I will define the problem for you. Right? Okay, turn it back. On right now. I show up it's an example and a very easy way, and not just solve the problem. Right? I just show you first. Okay, identify is very easy, right? Very easy. Okay. And next step, you're going to convert for F4, right? And write to the PLC next. Okay, the PLC, click OK. I click start, right? And the lamp being lit, right? Okay, okay, if I hand off the button and it extinguish and turn off, right? Turn off. Click again, okay, show up. And I leave my hand, it's okay, it's drop, right? And extinguish. This means it will start and stop just only one using only one button, right? Okay, if you can remember, I told you before, right? If you need to speed out the one button to the two buttons, right? Two buttons, one stop, one start, one stop, right? Use the interlock circuit, right? Okay, if you remember the electro-pneumatic circuit, right? I told you before, right? How to control by using two push buttons, one start, one stop, right? I use the interlock circuit, right? Okay, turn it back to the area for write the diagram, write the ladder diagram. Okay, edit already. Okay, going to this, right? I just use K, right? Electro-pneumatic circuit. I have used the K, right? Delay, right? The hardware K. I define K1, K2, K3, something like that. And right now we come to the auxiliary relay, right? The software relay. Okay, never have is your the physical one. Never have support one. That is software one, right? Okay, I just change to M because the name for auxiliary relay I use in the program, right? The program use about the M, right? The M. Okay, that means why did I use the M1? Right now I'm going to create the parallel. Parallel is the M1 again. Okay, like this and this. Okay, I use the stop button. Another push button. Okay, I define is the X21. Double click on here and define the normally close because normally close is cutting off the line. Okay, cutting off the line. I use the normally close. Okay, X21. Click OK. That's it. And the next step, I need to control the red color traffic light. Red color traffic light. I will define the time, right? The timer delay turn on. How long red color is turned on? How long is the color red color is turned off? Right? I need to create it. Flickering red color traffic light. Flickering. Flickering. I will use the diagram control on figuring of the traffic light. Okay, start up and define the contact M1. After you push start up the M1, right? It is the contact, right? Okay, define the timer T1. Create the space, right? Little bit space. I define 1 second, right? Normally you never have multiply 10, right? The default normally okay 0.1 millisecond, the millisecond. When you need to set up the time, right? Longer, you need to multiply by 10, that means 1 second, right? 20, okay, multiply to 0.1 become to 2 seconds, right? Something like that, right? Okay, it's okay. 10. Okay, I need to turn on 10 seconds, 10 seconds, 10 seconds for turn on the red color, right? Okay. Okay, right now I will set up T1, right? After uh, after the coil timer is done, the contact T1 change state to close, right? And let the power supply to Y0. Y0. Okay, click OK. And I need to create another line, right? Another line. Okay, I need to speed the line from the T1, right? T1 line, I speed to another line below. And right now, and the area is not enough. I need to insert line. Okay, create more space. Okay. So I will have the space for create the vertical line already, right? And this time I need to set up the timer, another timer for turning off the light, right? Turning off the light. How long, right? I will set up right now. T2, right? K 10 seconds, right? The 10 seconds. And if I need to define how many time the figuring for red color, and the red color is turn off, turn on, turn off, turn on. How many times you need to figuring off the red color, right? How many times, right? I define by counter. I use the counter. The counter is the software as well. The software is not the counter, is the real one, right? The physical one, and not being like that. I will use the software. I use the software, right? You save across. You use the software, counter and timer, right? And right now the same thing, right? Not enough the area below, right? I need to continuous create another line below. Okay, not enough right now. And you click insert a line, right? Okay, click on here and make sure you activate it's a F10 already, right? Okay, you click on here and define the counter. Define the counter. This one counter. Okay, C1. C1 um, T time, right? T time. Okay, I define T time 3 times, right? Okay, right now. Okay, like this. Okay, the T timer 2 for turn off, right? When you need to turn off, you need to cut off the timer 1, right? Because the contact the timer 1 let the power supply to the Y0, Y0, right? If the timer 1 cut off and turn off, and the contact is come back to the open again, come to the open, okay, Y0 is turned off, right? Okay, I will set up. Normally close the timer, the contact timer 1, timer 2, sorry, timer 2. Okay, it's done. I need to test. Okay, what happened in your ladder diagram? It can be work or not. Okay, it's convert first. When you convert, okay, change to the machine code already. You're going to the top left. Okay, right the two PLC. Okay, have done. I'll show you what happened. I already revised about the ladder diagram, right? You click on here. One is our figuring is turn on, turn off, turn on, turn off, right? Okay, turn on, turn off, turn on, turn off, right? Okay, it's correct. Okay, turn back to edit the ladder diagram again. Next step, I need to change to the zero color traffic light. The zero color is I set up and create the diagram control red, continuous control Y, yellow. The yellow is turn off 3 times, right? And the last one is you need to control the green color traffic light. Turn off, turn off, turn on, turn off. The same thing, right? How to do that? Okay, we'll show you. I need to control the traffic light yellow color. After the red color traffic light is done, I will show you. Next step, you create the contact normally open. C1, the counter when the timer, when the 3 times of the color red color is done, right? Use to take the contact C1 and open, right? And open and close because the 3 times is done, and the contact C1 is closed. Supply the power to the timer, timer number 3, right? Okay, click. And here C1. supply timer, timer 3, timer 3. Okay, supply the power to the coil relay timer. T timer 3 is K 10 1 second. Okay, take the contact normally open again to another line. I use T3, the contact for timer number 3, and supply to the yellow color traffic light, Y1. Okay, Y1. That's it. And I need to create vertical line below of the last line I have done before. I need to insert and space and create more space. And for the vertical line, I will create it. Okay. Make sure you press and keep turn on about F10. Okay, like this. And you create timer 4. Okay, create timer 4. Timer 4. And use the 1 second. Because turn off the yellow right, turn off 1 second and turn on 1 second. Okay, the same thing, right? I need to turn on, need to create the flickering of the yellow color traffic light three times, right? 3 times. Okay, insert more space for the another line. I will use the vertical line and use the counter, define the counter function at the C2, right? Okay, three times. Okay, this one the camera normally open the contact time for normally close. Sorry. Yes. Test convert and write to the PLC. Done. Test red color flickering 3 times. 1 2 3 and 0. Oh, it's okay. Miss the function already, right? Okay, turn back. Why? What happened? Why is run? And the result is a miss function. Okay, I add up the counter. When the counter done 3 times, I need to take the contact normally close, right? Cut off the circuit in this line, the M1 line, right? Double click on that line circuit, right? Okay, I will use normally close, set up the contact. Sorry, the counter C1. Normally close, right? And as well, and also in the traffic light yellow color, the same thing. We add up the number close C2. Okay, test. Let me test this letter diagram again. Now write to the PLC. Yes. Okay, click 1 2 3 yellow 1 2 3. Okay, done. Okay, 2 color traffic light is done, but okay, little bit is mouse function. Little bit is the time second is turned off. The round number 3, the figuring round number 1. Okay, perfect. 2 perfect. 3 a little bit is it's not perfect, right? Because the time is not completed 1 second. Okay, I just revise the ladder diagram again. Right? Edit ladder diagram. Okay, click on the edit ladder diagram button and go down and analyze what happened. Why the round number 3 for figuring the traffic light is not perfect. Right? Okay, you see about here because it's a okay. The time is count 10 sec. The time number 3 is done. Right? The contact is changed to open. Right, and not yet to count 10 seconds. Right, that means I need to add up the line. And I define the timer. I define the timer, the new timer. Okay. I add up the new line about that and create the C1. Create the C1. Okay. C1 and set up the new timer. Time number 5. Timer number 5. And I need to delay 1 second. 1 second. Okay. I take that. I take that. I take the contact of timer T5 instead of C1 number is close become to T5, right? Because I need to delay 1 second before you cut off the line of the M1. Okay, turn off the power at the timer T1. Right? Okay, something like this. I will show you. I will need to edit another line. Okay, the same thing for the yellow color, the traffic light, right? Okay, I will add up another line. Okay, use the contact timer. Sorry, contact counter number 2, and set up the timer number 6, right? Number 6, K6 and K10. Okay, done. I change this one. We come to my timer T6. Okay. And the last line, I need to insert, right? Insert another line, and because the counter must be resetted, must be resetted because they turn to the zero, right? When the counter stop, the counting to the three, okay, then why do we define it? How many times you will set the counter? The counter is run until the last number. Okay, for me, I use the three, right? And count to 3. Okay, it's still being 3. Clean 3 number. If you never reset it, okay, it's still the value to be 3, right? If you need to run the new cycle again, you must set up and you must reset the counter become to 0 again. Right? This is important, very important. Okay, let me reset the counter. Reset the counter for 2 counter. It's counter number 1 and counter number 2. I need to reset back to the 0. Okay. And add up the new line. Insert the line. Use the numerically open T6, right? T6 and reset, right? And you need to use F8. F8 is the rider function, right? I need to use the reset function for the counter 1, counter 2. Okay, I will use the function reset. Okay, I need to use the F8. RST, RST, the counter 1. Okay, done. And another line, reset the counter number 2. Insert another line for Add more space for me. Insert a line. Okay, this one. And this the function. Add the function reset. RST counter 2. Okay, done. And convert. Red convert. T 3 times. Okay, done. Yellow 3 times. Red again. Right. Okay, perfect. Have done already. It's well done. This two two traffic light. The color is red and yellow. Okay, turn it back. I reset to the start point again. Uh, okay, the last one is a green color traffic light. Okay, I need to define you, assign your work, right? You will modify this ladder diagram, right? You follow me step by step. You take that knowledge, right, and modify and apply the ladder diagram. Okay, so the problem is last one is the green color. I need to define the green color. Okay, figuring 5 times. Okay, 5 times, right? And the time, right? The time, how long is the turn on the green color? How long? Okay, you define by yourself. Okay, different for me, right? I use the 1 second. You can use 2 seconds, 3 seconds, right? Turn on 3 seconds, turn off 2 seconds, something. You define. Okay, accept you. You said write me. Okay, accept that. You need to define the time turn on, turn off, right? Okay, this time you can define by yourself. Okay, that's it. And this one, right? The timer. If you add up the pin color, right, uh, between C2 and timer 6 contact T6, right? You insert and okay, make the solution for controlling the pin color. Okay, the obviously we did, and last line should be okay. The last timer, okay, the reset at all. Counter maybe it's counter 1, counter 2, and counter 3. Counter 3 for the pin color, the pin color counting number of the time, figuring of the pin color. Okay, I bring you to save your work, right? Your work. Okay, going to the project. It's a project and save. Click on the save button and going to where is the your where is the storage you need to keep in the your computer, right? Okay, I will going to G for me I need G drive I save the work to this. Okay, your class, right? Your class. Okay, I set up about traffic, right? Uh, figuring, right? figuring, figuring traffic, right? Three traffic, right? And save, right? Okay. If you need to revise some code in the data diagram, you saved it before. Okay, maybe I will show you. If I okay leave off this, right? I need to turn it back. I turn it back, right? Okay, are you ready to revise some data diagram, some part of the diagram? you're going to edit ladder and go project and open project and point to where you kept in your file to, right? You're going to that location. OneDrive for me, right? This is the area I kept my work is in this folder. Electric and PLC and this one. Okay, you're going to select on the figuring, traffic right, my file, open. Okay, done. Okay, you revise containers. Uh, what the part you need to edit, right? You go on to do. I'll bring you to next exercise. You come back to the main menu. Okay, skip over intermediate, the challenge. I go into advanced challenge, advanced challenge, and going to focus on the forward, reverse, rotation control. Click on here. Okay, bring you to the new exercise, new virtual plan. Okay, the complicated problem. Okay, look into the information of this problem. Okay, create a X20, the push button. When you click the push button X20 and the supply command YO, and the YO for the hopper is turn on and turn on when you turn off the push button and the YO is turned off as well, right? Okay, you push turn on the YO and you release your hand, the YO is stop, right? Where stop, and this one is item number 1, item number 2. Here the switch, toggle switch. When the toggle switch 24 and the conveyor is running, it's roll up, it's running, go forward. And when the X24 turn off and the conveyor is stopped. And number 3, the large side of the part, right, detected by the three sensor, and the sensor 0, 0, 1, 0, 2 is on off the sensor is turned on, mean the object is large, right? It's a large side, if X1 and X2 are detected and XO turn off, right? XO turn off, it's not detected. And mean the object is medium size, and the smallest size is sensor X2 detected, and the XO X1 is not detected, not be detected. Okay, and the sensor, three sensor define the size of the part. It come from the conveyor, right? Come from the conveyor, and this zone is a sensor. They come back to the information. Next information, after the sensor, use the sensor 3 sensor detected the size of the part, right? And number 4, X3 detected mean the conveyor number 2 stop. If large size and smaller size detected is the large size or small size, this pusher. The pusher is push the object slide down to the lower conveyor. It's a lower conveyor. If the right side, the conveyor go to right. Okay, goes to right and drop the object to the container L. If smaller side, go down to the second conveyor and go left drop to the container S, the name S container. And the next condition, if the medium size is the medium size. Stop at the sensor number 3. The medium size go past the pusher. It stop. Don't push the object. Go down to the second conveyor. Medium size go along with the conveyor number 2. Stop the end of the conveyor. Let the robot pick up the object and rotate to another side and drop down to the container M, right? And turn it back, waiting the new part is coming again. Okay, this is the idea of the problem. Information is problem, the problem given by this program. Need the virtual control, the virtual automation process. Okay, let me edit ladder diagram to coding. Create a ladder diagram for the control this automation process. Start, right? This push a button and control Y0 to supply the object to the conveyor. The first conveyor Y1, the second conveyor use the output Y2, and the conveyor is Y5, the second lower level of the conveyor, Okay, so go forward and revert Y6, go forward to Y5. The sensor detected at the container L, X12 is a sensor detect the object drop down to the container is L, and sensor is detected the object is small size going down to the container S. Right, the F10 detected at the end of the conveyor number 2. The X6, the sensor detected completed the object stay in the container M. Okay, that's it. I created a diagram related on the electro-pneumatic system using about the chip digital method. Right? I have ever taught you already in the electro-pneumatic system. Right? I will use that way and create a diagram to control the process. Even if different the output, right? Because the electromagnetic I told you before, I use the actuator, linear actuator, and the solenoid valve direct output, right? Control change the position of the main valve, right? And right now the Y is different. The Y the control conveyor, the YO control the supply object to the conveyor. The robot Y4. Sorry, robot. Okay, correct. The robot control the output Y4, right? Okay, this the hardware is different, but the diagram is the same. I will show you. Click on F5, X20. Okay, click OK, and check it out about it is the start point or not. Okay, it's not start point. It is a program not around the system running, right? Because it detect and protect your system must be X4. X4 detected must be the start point, right? Okay, and that means I need to add up X4. X4. Okay, F4 and numeric course, right? Numeric course because the chip leader, the next group signal, it's it cut off the circuit, uh, the current signal, right? Because the diagram I ever taught you before the diagram. Okay, next is the numeric course and M Okay, I need to use the M4. Why the M4? I need to explain you again. Right? Because the number is close, right? Is the number close. Okay, click on here. Create the output. Output is M0 because if you compare with the electro-pneumatic circuit, right? I use K1, right? K2 cut off the line K1. The K1 is set up K2, right? Something like that. Give the same idea. I use it uh, M0. Set up the interrupt, right? M0. Okay, draw the right, shift and go to right, and click the button. And don't forget, keep the F10 turn on, right? F10 turn on. Okay, below the taskbar, the taskbar below that, to keep turn on F10. Uh, okay, right now ready to draw the line circuit by yourself. Okay, click on here and go up, right? Okay, draw is the vertical line. Okay, done. Go down. This is the group number one. I use MO, M0. Uh, uh, next, MO. Sorry, M0. Okay, M0. This one. Make sure M0. Okay, it's YO. Y0. Done. About this. Okay, this step, right? I click the start button and let the object go down to the conveyor Y1. Right, the conveyor Y1 turn on and roll up. Zero up carry the object to right direction. Uh, right direction and go to the sensor. Right, the sensor checking up about what side the part is come into here, into here over there in front of the sensor. Create this. Okay, if x0. Okay, next x1, x2, and okay, number equals. Okay, M0, right? Let's go to the M1. Okay, I'll put M1. Okay, this M1 mean X0 turn on, X1 turn on, X2 turn on. Okay, send the signal. Mean the object part, the big size, the large size come into the conveyor in front of the sensor. Keep M1. Okay, I need to copy to here and copy to here, right? Okay, let me save this first. Save. I'm going to the location. You need to keep this file too. Okay, going to drive. This is my computer. I need to keep the file to over here. Okay, I set up the for forward, forward, lever, control, control, save. Okay. Uh, okay. Not yet convert, right? Okay. Save again. Uh, yes. Uh, okay. Set up the sensor. Detect detect the large size. Okay. Use this line, and medium size. Use this one. Another line. Okay. The next line. Define. Uh, this one numeric cost. Because the medium size turn on x1 and x2. Okay, this one become to m2, m2, and the relay, m2, m2. Okay, this one numeric close. Detect using is only one sensor x2, only one sensor x2, right? Something like this. Okay, this one should be changed m3 for detecting the smaller size, m3, m3. Okay. Okay, need to keep the sensor. Keep the sensor. Okay, detect M1, M2, M3 using this 3M for checking the large case, smallest case, and medium case. Use 3M to detect along of the way, along of the problem, right? Case by case. I relate only the problem given. Explain this information. Okay, check again. 20. X24, I forgot, is a setup. The code that the game code. Okay, this is the turn on of the conveyor Y1, right? On the Y1. Okay, turn back. Right. Okay, I insert the line. Okay, before X0 line. Okay, I insert the line. This one and use X24. Uh, okay, turn on the conveyor Y1. Okay, done. This one is M0. Okay, because the previous signal group, right? Set up the next group, right? Next group. Okay, this is why M0, right? M0. This is the control Y1. Okay, next M0 to M0, M1, M1, M1. Slow M1 and normally close M5, fine. And this one M4, M4, M4. It's right the auxiliary relay M4, M4. This one is big F10. Is a parallel M2, M2, parallel M3, M3. This one M4, M4. The horizontal line. Okay, delete it. Okay, we check it out. M5, somebody calls M. Okay, this meaning of this line. When I use the chip leader circuit, okay, this one M0 is a group number one. Group number one, I use the M contact M0. Is when the contact M0 turn on and become to close and supply the power to YO. When the YO detected and move the conveyor go forward, and this one and this line is the X24 turn on of the conveyor Y1. And this next the sensor is three sensor detected in the side M1, M2, M3, right? After that, on of this, the sensor three three case, large case, medium case, and small case, right? Okay, going to create the relay, the software relay M4, and this one is okay lock. It lock it keeps it turned on, right? Until if M5 turn on, okay, let the circuit is cut off the circuit. Okay, this is number close. Okay, going to step. Sorry, I convert first. Step. Right? Yeah. Next step. Next step is the generator is normally open after M4. M4 turn on the conveyor Y2. Second conveyor is continue as operating with the Y1. The Y1 turn on and Y2 turn on as well. That means you just create the output. Y2 is the output. Output from the PLC Y2. Okay. Right now it's signal group number one M0. M0 takes the output, contact M0, supply Y0, right? And X24 turn on the conveyor number one. Next, the sensor. The sensor is T sensor. I need to see C sensor. Okay, and in the one time use the one of the three sensor, and one of the three. Okay, detected. This one object, right? One object is passed, and the conveyor carry on the object, and just one of three, the condition detected, and detected is the sensor, one of three sensor detected, right? And then the sensor did come in to another line. This is the sensor MO, right? And before the contact, and set up the next group sensor, next group signal, right? MO, right? And this the sensor is come from this three case, three case, right? One of three detected. Okay, I put into here, right? And use this one. The next signal group is cut off the line previous group, right? Okay, this one the previous group is the M4. M4 is can be locked, right? Use the interrupt, right? Relays on the chip leader method. Yeah, that's the principle. It's the rule of the chip leader, right? Okay, right now use the contact M4 supply the output like this. Okay, next. When the object pass to the conveyor number two, all right, conveyor number two carry on the object, okay, pass the front of the X3, the sensor number three. Okay, I use the sensor number three. When the sensor number three detected, okay, right here, and this one, you create the memory open, right, for the M4, M4, and this memory course, right? You cut it off by M5, M5, and go to sorry, M6, M6. Okay, this one is M, the output, M6, M6. We turn on. So, oh, sorry, it's miss the number to find. Click OK. This one, M5. Next, use the contact M5. Supply a signal to M5, and the condition is if big size is M1. I I set up the case, the big size, the last size, using M1, M5 the represent the last size, M2 represent the medium size, M3 represent the smallest size, right? And right now I need to check up the case, okay, if the last size and smallest size must be going down to the lower conveyor, and if large go to right, left go to small size go to left, right? This one I will check the condition, what the last side part come in, okay, go down. So on the side come in, go down, and the medium side is go on to the robot pick it up, go to the container M, right? Pass it to the container M, right? Okay, this one, okay, M, okay, use the Y3 pusher. The pusher is to push Push the object go down to lower conveyors, go down past the lamp uh, incline table, go down to the second conveyor. This Y3, IT, and this one create the parallel, right? Because use M1 and M3, M1 and M or sorry, or MT, not and M1 or M3. If X7, the sensor detected the sensor detect the object is going down to the second level is a lower conveyor, right? And X7 detected the object, what the object pass past the front of the sensor. That means detect is the object, right? Going down to the second level. Okay, use the X7. Okay, when the X7 detects it, right, and check it up, it's a continuous step from the Y3 the Y3 working, and next step, the sensor detected the object going down, right, and it show the confirm about continuous step from M4, M5, right? Okay, M5, M5. Next output, M7, M7, and output is M6, right? M6, M6. M6. Okay, okay. M6 contact, six contact, M1, M1, right? M1 going to, okay, you need the conveyor carry on the object on the conveyor number 5 and go forward and drop the object down to the container L. Is why with M1 is large object, right? Large part. Y5, Y, Y5 go forward. Oh, sorry. Y5. Okay, if X12, the sensor check at the end of the conveyor, the lower level, the conveyor detected is the X12. Check if the object path to the conveyor go down to the container. X12, X12, and M6, right? M6, M6, and now the course M7. Generate the output Y, okay, X, M, M, M6, M7, and M8. So M, M7. Yeah, this one M8, M8. So, M8, M7, 7, M7. Now we open. Okay, try to supply the power to the output. The output is I will define the output lamp Y20, right? And this is a sensor. Sensor the object pass to the container L. Y20. Okay, detected using the LED lit mean is trying to tell the system about right now the container contain the object is the last one. Convert and save. Let me test the radar cam. First version and not completed because I just consider about last one. Last parts go down and go to right. Go to right of the second conveyor, second version, and the lower conveyor is go to right. Okay, let me test it. It's convert already, right? And right to the PLC. Okay, done. Check it out about this click. Okay, this running the Y1 conveyor and push button start. Let the last one go down the conveyor and go to right of the lower conveyor. And right now it's not completed and not drop down to the container L. Okay, it's got start. The end of the conveyor, the end of right. Okay, the end of the right, the conveyor. Right. Okay, this one is got start. Okay, check it the ladder diagram. What happened? Why why the last part is not going down to the container. Okay, I will keep it. This one is Wi-Fi. Wi-Fi is go forward. They carry the object on the top, drop down to the container. And right now it's not drop down and got stuck and stop at the end of the conveyor, right side. Okay, I will solve the problem. I insert another line, and I need to keep uh, M7 M7 keep running. Keep running Wi-Fi. Okay, put here. And here, vertical line. Okay, convert. Okay. Oh, and this time, the end is the last line of the last one, last piece, right? Last part piece, that one. Okay, I will take this, take Y7, M7 to cut off this sensor. I never have a cut off. I not just cut it off this line because I need to keep the M1 because the M1 represent the last pass, right? Represent the last pass. And M2 represent the size of the medium. And the M3 represent the smallest size of the part, right? And we need keep all the way on the way of the letter line by line until the end of the line. Okay, M7. I take this one, create the numeric codes because I need to cut it off this line M1. Right? Okay, I just numeric codes cut off the circuit this one. Okay, because the last one stop over here. Right? Okay, convert and check it out. Oh, sorry, line to the PLC. Oh, okay, done about last one. Okay, that is the process. Okay, completed for last one. Okay, click again. I need to uh, yo create the part new one. Drop down to the conveyor y1. Okay, click again. Okay, drop is the medium size. Okay, okay, stop, right? Okay, it's not completed. And okay, it didn't. This is correct because I never done about the diagram. Control the medium size, right? Control medium not yet completed because not yet to do this. Okay, I will turn back, right? And reset again. Okay, create the diagram support the medium size. Support the medium size. Okay, where is the uh, where is the where is the diagram should be inserted. I need to insert the diagram new line to this location. Info M5 is check it up about this one, M1 or M3, right? Turn on pusher, push the object, go down the lower conveyor, right over here. If uh, if M2 if M2 is go on continuous running of the conveyor Y2, continue as running. Okay, bring and carry the medium sign go another end of the conveyor Y2 and waiting the robot pick it up and drop down to the container M, right? And that means I need to go to containers, supply the power to Y2. Okay, I need to insert the line over here, right over here. Okay, take M5, M5, okay, and M2, and M2. Into represent the medium size of the object of the part. Okay, go convert again. Okay, not yet. Okay, I need to go on next letter diagram line. Okay, right now I just completed. Keep going about the conveyor Y2. Y2. Okay, I need to insert the line. Okay, insert this line, the medium, right? X5. This here is a sensor. X5. X5 and M5 and M5 and M5 numbering close, numbering close. M8 5 6 and 7. M7 already have, right? I have done about M7, right? M7 and okay, I need to choose M8. Oh, M8. Okay, sorry. I need to use M8 for this because another size, the smaller size, I need to use M8, right? Okay, I keep M8 for smaller size and go lower conveyor and bring. I need to take the conveyor, carry on the object, drop down to the container S, right? I need to keep M8 for smaller size. Okay, let me use another name. 8. Okay, already. 9, right? Okay, 9, not yet. Uses. Okay, use it one. 9, right? M9. This one. Also M10 because M9 for the relay, right? The relay. Okay, insert. M9. Further right. Take the contact M9. and randomly open. Okay, take an X file and trigger robot Y4. Trigger the robot, turn on and move the robot. Going to pick the object up from the location X5, right? The X5, the sensor detected uh, when the part stay on the table. The X5 is detected and turn on the robot. The robot is working, right? It's working, going to picking up the object and pass to the container M. Uh, okay, this is M9, M9, Y5, sorry, Y4, turn on, Y4. Okay, this side. After a robot pass the object down to the container S, the sensor is X6, the sensor X6 detected. That means, okay, right now in the medium size completed process. Okay, the object stay on the container M already. X6 detected that I must use the sensor X6 M9, M9 numericals, uh, M0, M0, because the first one cut off the last scoop, right? The scoop one cut off the circuit by scoop one. Okay, cut off the circuit of the last scoop. Chip leader, chip leader rule. Contact in the tip on the auxiliary relay. M10, M10, M10. Okay, just insert a line, generate is a parallel circuit, right? Interrupt the M10 keeps turn on until the next group. Okay, until the next group, it means the group number one turn on, right? And the last group is close and turn off the line. The power is gone. Hit M10. Okay, chip, draw vertical line. Done. Okay, I will use the contact of the M10, contact M10. They supply the power to the Y22. Okay, the status show up. The status show up. It's status identify Y22 for the container M. Container M detect the object. Okay, stay inside of the container. The LED lit lit by the output Y12 Y22. Okay, I will set up the output Y22. Okay, something like this. Okay, we turn off the sensor. This is the sensor. This over here I turn off because I already done about the medium size, right? Just M10. I need to turn off this side. Yeah, right to the PLC. Okay, toggle switch to on, right? Then on, and this is turn on the Y1 the conveyor number one, and click is unload. It's unload object to the conveyor. Okay, done about this. Okay, the last one, last part done. Okay, the small, the medium part, right? Okay, the robot picked up and paste down to the conveyor M and turn back to the start point again. Okay, stop. Yes. Uh, okay, Y22 is turn on, right? The status is tell you about right now the medium size pass to the container M already. Okay, that mean okay next. I need to click and unload the object, the new object to the conveyor. Okay, part number three. It's small part, right? Okay, the small part not yet completed because I never done it. Right? I never done it. Okay, I will back to uh, edit, right? Edit the diagram again and reset back to the start point. Right? And I need to save it first. Save it first. Okay, the smaller side. Okay, I will set up about this. Oh, sorry, this where I need to insert the new line to X3. Oh, right now. Okay, analyze the circuit diagram. The medium size I use it. I use I use M9, right? M9. Yeah. Okay, in this one X3 over here, X X3 detect the object side. If the last side, the pusher is work. It must be working, right? And this small size Y3 must be working too. And X3 indicated it's medium size. The conveyor is keep going, right? Keep going, carry on the object pass to another end of the conveyor, right? This okay. These the two case. Case number one or three, right? M1 or M3. Case number one. Okay, number over here M next signal group, right? Because it's a split to two way number one pusher working and push the object one or three down to the lower level and the conveyor lower level. Does it mean this over here? This one X7 pass to X7. Another case pass to X5, right? Two case. That means you must cut it off by 9, right? Because it's the next group for the second case. The case number one is pass M or 3 go down to the lower conveyor. That means you must cut off chip is the rule. Right? Yes, thing like this. Fine. And go down to this case. Right? This case. Oh, sorry. Okay, okay, this is a medium size, right? Until the M10. M10 is the medium size. And this one is the X7 detected in the front of the inclined plane, is the lamp, right? Okay, inclined plane, the X7 detected the object go down to the lower conveyor. This to this, right? Okay, another case, quick insert. Another case M10, M6, right? M6 Another case M3, a small size M3. Go to Y6. That is the lever direction of the robot conveyor. There is lever to reps side and need to keep the object of the part inside of the container S. Is Y6. Y6. When Y6 work, right? Okay, I need to okay, use this Y6 X 11 M6. Okay, these are two case, right? M6 there are two case. Case number one, the M6 and X12, right? This is the right side, the right side. Okay, the last one, last part, and another case, uh, smaller side on the side. Okay, sensor X11 detected. Okay, that means why I use the X11 and M6 because M6 is speed to case. Case number one live, case number two is left, right? Okay, going to here, and this one M0. Okay, click on here is M8, M8, M8. M8 contact normally open and turn on the LED status. Uh, LED to show up and show up or tell you about what is the status right now. Right, the status is small parts stay inside of the container S. Okay, Y Y21, Y21 is the output. Okay, the smallest size Y8, M8, normally close M8, the small size. Now this one two case M M7, M6, M6, M7, and M8, right? But because M6, okay, separate two case, two case. Case number one go right, go left, go right for last one, go left to smallest one. Okay. M6, M6, M0, M8. Okay, two case, two case cut, cut the circuit. Uh, the M7 detected. Okay, use MS7. It's cut off the line, or M8, right? The small size. Small size is done. The contact of the course is cut off the line M6. Right? Because next group for M6, next group for M6 is M7 or M8, right? Okay, convert. Yes. Oh, okay, not pass down to S, right? Okay, this is edit. Okay, Y6 is okay. Keep going. The conveyor is running until the object pass down the container S. Okay, into this M8. The parallel circuit mean okay M6 M3 okay let the power supply to the Y6 or M8 is turned on okay supply to M8 too it is a two case can be used for supplying the power to the Y6 okay convert again and I2 PLC. Okay, it's correct. The medium size go past to the container M. The small size stop. Okay, go to the left side. Okay, it's correct. The big size go down. Big size go down again. Okay, correct. Okay. Okay, perfect. The running is completed. I click edit other diagram and reset again and going to save this project. It has done very well. This is a radar diagram. I use the chip editor technique to create the step by step, right? Okay, you keep the rule of the chip editor. It can be used for solving a complicated problem like this. Right? Okay, you see the same pattern, right? And use the logic idea to analyze some trick, right? And in the overall, I use the chip leader, right? Did the pattern, right? Okay, did the pattern and add up the spatial, right? The sensor, right? The sensor is okay, including right is one line of the chip leader. Okay? All of this is I generate is a three case, right? M1 or M2 or M1 or M2 or M3, right? Just like this. M0 is the come from the previous scoop, right? Previous scoop, and this one the next scoop is cutting off the line, right? This is the rule of the chip register. Okay, this one is the output, right? Take the contact of the M4 and supply to the output in the the electro-pneumatic circuit, right? I use it in the right zone, right? I separate the two zone, zone left side, right? The change the group, right? And change right side, supply the output, right? And this time I pull the output right side to the to to press nearly the group chain, right? The signal group and chain to the group by group, right? I going to culture, right? Culture is a separate group, right? And this one is generate the output, the signal, right? Something like this, right? Okay, and this one is the technique, right? The trick of the chip repeater. Okay, in this case, because it one, because it one have the condition if, right, the logic if condition. If condition is a one, and there are two cases. It start from this M5, right? The two case later. Okay, case number one. Okay, last part. Case number two, smallest part, right? That means why I need to take the number close, cutting off this line, right? One is the last one. Okay, last one is contact number close. It can be cut it off, right? Or the smallest part, cut it off and the line, right? If you detect, the system detect is smallest part, right? Use the M9, cut it off the line. Okay, the technique is the apply the chip to this complicated case, right? Complicated case. Okay, the same way two case, right? The if condition if else, right? If this small part, if this small part is the last part, right? To case like this. Okay, this is the idea. Okay, I need to make yourself understanding this letter diagram the benefit for you if you take the practice time you will create a letter diagram is control in the automation process, the real one. Okay, this video I think it's enough for this. Okay, don't forget to save again enough for this. Okay, thank you.